Good day, class. This is Benatiku, and I'm here to present this project work. It's going to be fast because I have a lot of information, but the time is not that much. So we're going to be quick with it. The next thing we're going to look at is the table of contents, as you can see right there. Um, the background information of data, that's project description. This data set is for premium financing company, and it consists of 47 variables, but we're going to reduce it a bit, do data selection, variable selection, and to find out which APR, which variable has influence on borrowers canceling their loans. We also want to understand to be able to predict, to see which variable um, is influential and can help us predict future cancellation, so as we can know how to prevent such losses. Our first hypothesis is to some of the things that we're going to look at for the first hypothesis is going to be APR, whether APR increases, the number of people canceling their loans will also increase, or the second one we're going to look at as premium, which is in connection with credit score and risk score. If it increases, what are borrowers going to do? Now we go down and we did I did some created some extra variables for this project work. So we're going to have regions, we're going to have amount plus interest, and we're going to have changes in risk score and credit score. When it comes to the processes of analysis and results, we will begin by data cleaning and transformation. So we first import our packages, we move on to loading our data. Then as you can see, this is our data. Then we move on to finding data information. So we look at the items that have strings, we have items that have objects, and we have numbers. So these variables that have numbers, strings, and objects. Then we move to how many, we look for missing variables. Then these are, we can see the borrower credit score has 46,356 missing variables. Risk score has 100,000 111. Then we replace all now values with E. Replace all now variables with E for risk score. Then we'll go ahead to replace all now values uh, with 6, where 6 represents no score for um, borrower credit score. And also we replace no score with 6 too. We then handle the missing values for exposure. We find a median and replace it with the now value. So we find the median, which is 218.82. Then we replace all now values for exposure with 218.82. Then we drop all other now values. Then we find our data information again. Now we look for missing values, and we can see we have no missing value. Now we can go. Okay, we're going to talk about business intelligence and data visualization. I know I have a lot of stuff to talk about here, but due to time constraint, we're going to reduce it to about 2 minutes. So first of all, we're going to look at indexing. We make maturity data index. Then first, we're going to look at the total number of cancelled and not cancelling. So we have 12,613 for cancellation. Then we move on to the next. This is a visualization showing it. Then we move on to cancellation and exposure. We have a negative relationship right there. The fitted line shows the negative. APR has a positive relationship. That means as APR increases, cancellation also cancelled also increases. We have the region with the highest premium, that will be Southwest. Um, we have the bar chart to show that borrowers in each region who cancelled. We have Southeast having the highest, 6,265, and the pie chart to show that. Now we move on to correlation, which is EDA, explanatory analysis, data analysis. So first of all, we start with correlation before getting damage. So we're going to see the relationship between cancelled and other variables. So as you can see, we have cancelled right here, and these are the relationships. So we can see um, late charge having a positive relationship, premium has a negative relationship, payment has negative relationship with cancel, and it is positive and negative. Positive relationship means as late charges increases, cancellation will increase, and as um, payments received decreases, um, cancellation will increase. Here we're going to do statistical inference, and we're going to test to see if the dependable variable cancelled is the same as um, the variable independent variables. So we're going to do one for APR and cancel. As you can see, the value is 0.000, and our null hypothesis says the two means are supposed to be the same, but since we have a low p-value, we fail to accept the null hypothesis. That borrowers who did not cancel and borrowers who cancel are, that means they are not the same. So we're going to talk about our classification analysis, regression analysis, and deployment and cluster analysis in all. We're going to put all of them together since we don't have much time to go into details. For our classification analysis, after declaring our x and y variables, we did an algorithm test, and we uh, used random forest because random forest had the highest um, area under the curve, which was random forest gave an accuracy of 96%, um, with 26,314 borrowers not not canceling their loans, and 286 misclassified as canceling their as not canceling their loans, and we have 754 as canceling their loans. We also looked at variables that are very much important in influencing the classification that we did. So we have payment received, late charge, premium and down payments, APR2, very important. Now our prediction on the data set gave us the first borrower not canceling as probability of 98% of not canceling. The second person has probability of 91% canceling. Now we move to regression, and we're going to talk about variables that are very influential in determining premium. With our regression, we want to also test for statistical significance of the independent variables, and we have all the variables being statistically. Using multiple regression, we're going to build our first model, and we have our coefficient right here. We have one for our first coefficient variable. Then we have our mean square error to be 8 point negative 20 exponential to 8.3. Then we have our variance to be 1. That's our R square is going to be 100%. We then use our X test to predict y to make our prediction, and we compare it to y variables. Then we deploy we do a deployment, then we attach it to our data frame. Then we have our visualization for our regression, and this is the actual I can see it properly here because the screen, I don't have the full screen. Now we move to cluster analysis. After our data preparation and data cleaning and everything, we do our variant test. Right there. Then we move to normalization and we check variance again right there. Then we go to doing variance check for the normalized data. Then we go to the big one, which is the Hopkins statistics. This test that tells you whether your data set is good for cluster. And we have a 0.997, which means our data is good for cluster analysis. To determine the optimal K value, we use the elbow method, and we have 4 to be our optimal K value. Using 4 as our optimal K value, we go ahead to do our cluster analysis, and we move on. We have 4 cluster analysis: cluster 0, cluster 1, cluster 2, and cluster 3. Then we get our centroid. We move on to adding it to the data set. The biggest point of this analysis is to do profiling. So we're going to do our profiling not with a normalized data set, but we're going to do it with the um, original data set. So we have a mean here, right here. Then comparing cluster, we have the cluster 0 having borrowers who have high default charges as compared to cluster 3 who have low default charge. They have low APR, but we have in cluster 0, they have very high APR. So this is how we profile our borrowers. Now we move to summary and recommendation. Our main aim was to identify variables that have influence on on the Y variable, which is cancellation, whether a borrower is going to cancel or not. So during our analysis, we found that the APR, premium, credit score played a major role in decision to cancel a loan or not not to cancel a loan. So in our recommendation, the managers for the company must look at the APR when they are trying to give out loans. For instance, we all know credit score have a very high influence on APR. So probably somebody with no credit score, giving it an APR probably might cancel their loan. But when the person has a salary job, we can actually calm down, reduce the APR for them. Managers are also can also look at late charges fees. Late charges when the late charge goes up, um, borrowers tend to cancel their loans. So they can also look at that. Down payment. Borrowers Managers must encourage borrowers to pay what do you call it late to pay down payments so as to reduce the amount of money they're going to pay at the time that they are given. So this is the end of the project work. I know we have a lot of information, but I didn't have much time to put everything in. And thank you for your time.